Question number 9. Particle P of mass 0.5 kg lies on a smooth horizontal plane. Horizontal forces of magnitude F Newton, 2.8 Newton, 2.6 Newton act on P. So, can anybody explain to me कि इन सारी forces को horizontal forces क्यों कहा गया? F Newton भी horizontal force है, 2.5 newtons भी horizontal force है, and this one must be the 2.6 Newton force. Why are all these forces horizontal forces? फिर vertical force किधर है?
मैम क्योंकि ओरिजिन से
नहीं तो हम vertical force किधर है फिर अगर ये सारी horizontal है? Horizontal हम usually कहते हैं ना जो x की डायरेक्शन में हो, और vertical कहते हैं जो y की डायरेक्शन में हो. तो यहाँ पे ये सारी horizontal क्यों है?
मैम क्योंकि y 0 है.
तो आपको लग रहा है y 0 है? इसका y 0 है क्या? इसका y 0 है क्या? इसका y 0? देखो असल में क्या बताना चाह रहे हैं वो कि ये जो कह लो ये ग्रे जो रीजन है ना, दिस कंसिडर इट एज अ टेबल. ये एक टेबल है, टेबल के ऊपर एक पार्टिकल पड़ा है, और जो तीनों फोर्सेस है ना वो टेबल के ऊपर ही फोर्सेस हैं. सो दैट्स व्हाई देयर ऑल हॉरिजॉन्टल फोर्सेस. ठीक है, एक टेबल है. हाउ डू आई शो यू अ 2D टेबल? आई मीन अ 3D टेबल. ये टेबल है, ठीक है. इसके ऊपर एक पार्टिकल है. ये तो उसकी फुट है टेबल का. अच्छा, इस पे एक पार्टिकल पड़ा है, और इस पार्टिकल पे जो सारी फोर्सेस अप्लाई हो रही है ना वो टेबल के पैरेलल ही, टेबल की सरफेस के पैरेलल. इसीलिए ये तीनों हॉरिजॉन्टल फोर्सेस है, because they're on the table parallel to the surface of the table. Vertical forces इधर क्या होंगी? एक नीचे weight जो नीचे होगा, और एक ऊपर नॉर्मल कॉन्टैक्ट फोर्स जो आर होगी. बट उनकी बात ही नहीं हो रही इस क्वेश्चन में. देर ओनली टॉकिंग अबाउट दोस 3 रेड फोर्सेस दैट आर पैरेलल टू द प्लेन ऑफ द टेबल. सो दैट्स व्हाई देर ऑल इन द एक्स डायरेक्शन, क्योंकि हम 3D परस्पेक्टिव से देख रहे हैं. So that's why all these forces are horizontal forces. Okay. So the directions of the forces are as shown in the diagram, where tan alpha is equals to 12/5, tan beta is equals to 7/24. अब क्योंकि हमें tan alpha given है, हम इससे ना sin alpha और cos alpha निकाल देंगे, क्योंकि वो हमें इसको resolve करने के काम आएंगे. Okay, so let's see. Tan alpha is 12/5. That means if this is a right angle triangle and that's A, then tan is opposite over adjacent, or perpendicular over base. And then if you apply Pythagoras theorem, 12 square plus 5 square, you get 13. So this is 13. That gives us sine A equals 12/13. So, and cos A equals 5/13, adjacent to hypotenuse. Okay. Similarly, we're told that tan B equals 7/24. Now let's form the right angle triangle here. That's B, that's going to be 7, and that's going to be 24. And apply Pythagoras on this as well. Square root 24 square plus 7 square gives us 25. Okay, so now we know what is sine beta. 7/25. And now we know what's cos beta. 24/25. Okay. Given that P is in equilibrium, find the values of F and tan theta. Now let's resolve these three forces. This one is opposite to theta, so sine component F sine theta. इधर भी बनाया जा सकता था, अब खैर मैंने उधर ही बना दिया. This one is the adjacent side, so cos F cos theta. Okay. Then for 25, I'm going to resolve it into 25. This one is going to be cos. And this one upwards is going to be, actually it's not 25, it's 2.5. 2.5 sine beta. And then for the force in the bottom or in the fourth quadrant, I'm going to resolve this using A. So there's a component in this direction, and then there's a component in this direction. So the opposite component is the sine component. It's 2.6 sine alpha. And this is 2.6 cos alpha. Okay. Now we have all the components resolved. Now let's equate the front and the back components and the up and the down components. So F cos theta should be equals to 25 cos beta plus 2.6 cos alpha. Okay. Okay. And then we're going to equate the, acha, now we know the values of cos beta, cos alpha. And do we all, acha, just give me a second. Okay, acha, अब हमें we know cos beta and we know cos alpha. So we're going to substitute that here. Okay, so this is alpha. So F cos theta equals 25 cos beta क्या था? This 24/25 plus, it's 2.5, not 25. And the other one is 2.6 cos alpha is this 5/13. So we have the value of F cos theta, which is this comes out to be 17/5.
7.
सही है, यही है मेरे पास 17/5
मैम
है. ये नहीं आता. लेट मी चेक.
मैम ठीक है,
यही आता
क्योंकि
है.
मैंने गलत. जी.
ओके, दोबारा भी चेक कर लेना. मेरे पास लिखा हुआ है कि ये 17/5 आना चाहिए. ओके, नेक्स्ट अब हम इसके y डायरेक्शन वाले कंपोनेंट्स को, मतलब अप और डाउन वाले कंपोनेंट्स को इक्वेट करते हैं. तो दैट इज, ऊपर एक f sin थीटा है और एक ये है 2.5 sin beta. So we have f sin theta in the up direction plus 2.5 sin b in the up direction and 2.6 sin a in the down direction. Okay, so f sin theta equals 2.6. Sine alpha is 12/13 minus 2.5. Sine beta is 7/25. Two point six into 12/13 minus 2.5 into 7/25. I'm getting 17/10. F sine theta comes out to be 17/10. Now we had to find f and tan theta. So now tan theta can be found by dividing these two equations. Let's call this equation 1 and this equation 2. If you divide these, f sine theta over f cos theta, then you get tan theta here. So 17/10 divided by 17/5, which gives us 5/10. So you're just left with tan theta is equals to 5/10. That's the value for tan theta. Next, you have to find f. So now we can find theta from here. Okay, so you can do tan inverse and find theta. So theta comes out to be tan inverse 5/10 or 1.5, sorry, 0.5. Shift tan 0.5 is 26.565051. Use as many decimal places as possible for you. Okay. And then we have to find f. So I am going to use the first equation. So f sine 26.565051 equals 17/10. So f is equals to 1.7 divided by sine answer. I'm getting 3.801. Okay, so the answer is 3.80 for f. So we found tan theta and we found f by resolving these three forces into their respective components and then equating the x components or the right left component and then equating the up down components. Okay. Next is part 2. The force of the force of F Newton is removed with the magnitude. Find the magnitude and the direction of the acceleration with which P starts to move. Okay. So the theory is going to be more or less same as the last question. Okay, when you're removing a force, this force, F Newton force, okay, so let me clear this. If these three forces are in equilibrium, that means that these two collectively, or the resultant of these two, would be balancing out the original F Newton force. So the resultant of these two forces would also be F Newton, and it's going to be in the opposite direction. That's why these two forces cancel each other out and the particle does not move. Okay. So what did F come out to be? 3 point something, 3.80. So that means this F is going to be 3.80 as well. And this is also 3.80. But we're being asked to find the resultant of the remaining forces. So that's going to be 3.80. Okay. Okay. Okay, I'm sorry, my kids are out of control. Okay, so कहाँ थे हम? Okay, yes. So the magnitude of the resultant of the two forces is going to be the same as F Newton force. And you have to find the direction of the acceleration with which P starts to move. Okay. So now when that F Newton force is removed, then the system is no longer in equilibrium. And the resultant of the other two forces is in this direction. It's in the opposite direction to the original F Newton force. So the particle will move within this in this yellow path in the direction of the resultant force. And the formula that you use now is not forward minus backward is equals to ma. It's the resultant force, which is the forward force. In fact, let me write forward minus backwards. Forward force minus backward force equals ma. Okay, so forward is this force, which is the resultant force 3.80, minus there's no backward force because that force was removed, equals to mass we are given in the question. Mass is 0.5 and A is what we have to find. Okay, now you divide these two, 3.8 divided by 0.5, which gives us 7.6 meters per second square. Okay, that's the acceleration. And you also have to give the direction. So you'll say in direction opposite to the original F Newton force. In direction opposite to original F Newton force. Okay, so these two were the homework questions, question 8 and question number 9. Okay, let's start question number 10 now. Okay. A small box of mass 40 kg is moved along a rough horizontal floor by 3 men. Two of the men apply horizontal forces of 100 newtons and 120 newtons. So that's 120 newton. Making an angle of 30° and 60° respectively with the positive x direction. The third man applies a horizontal force of 4 Newton acting at an alpha degree with negative x-axis direction. The resultant of the three horizontal forces acting on the box is in the positive x direction and has a magnitude of 136 newtons. Okay, so the resultant of these three forces, you're being told that it's in this direction purely. It's only in the x direction. And it's equals to 136. So resultant is equals to 136. Find the value of f and alpha. So to find f and alpha, we should just resolve these components. Okay, so this component is going to be f sine alpha, and this component is going to be f cos alpha. Similarly, for 100 Newton, this is going to be 100 cos 30, and that is going to be 100 sine 30. For the last force, it's up to you whether you want to use this triangle using 60 degrees or this triangle using 30 degrees. I'm going to stick to 60 degrees. So then in this direction, there is 120 cos 60. And in this direction, there is 120 sine 60. Okay, so we have to find the value of f and a. So I'm going to form the expression for Rx first. Rx is forward forces in the x direction, which are 200 cos 30 plus 120 cos 60 minus the force in the opposite direction, f cos alpha. Okay. So the resultant is already in x direction, which is 136. So equate this to 136. 100 and this is 136. Okay. Now simplify this to get the expression for f cos alpha. Which gives us f cos alpha is coming out to be 50 under root 3 after simplification minus 76. Let me check. 100 times cos 30 is 5 under root 50 under root 3. That is correct. And 120 times cos 60 is 60 minus 136 is minus 76. Yes. So f cos alpha is correct. Now we're going to equate the up and the down forces. So the up and down forces need to be in equilibrium because R does not have a component in y direction. So F sine alpha upwards plus 100 sine 30 equals 120 sine 60. So equate the up and the down forces. Okay, this should give us F sine theta, F sine alpha, sorry, which is minus 50 plus 60 under root 3. Let me check if that's correct or not. 120 times sine 60 is 60 under root 3, or minus 100 times sine 30 is minus 50. So yes, that's also correct. Okay. Now, since you have f cos alpha, f sine alpha, you can divide them, get tan alpha, and then take tan inverse to get alpha. Let's say this is equation 1. That's equation 2. Now we divide the two. So it's going to be f sine alpha over f cos alpha equals 60 under root 3 minus 50 over 50 under root 3 minus 76, which gives just tan alpha equals to tan alpha comes out to be, I don't know, it's some fraction I haven't calculated. Now we can take tan inverse of this. So A equals tan inverse of this fraction. This phase comes out to be 78.876. So rounded alpha should be 78.9 degrees. Okay, next we have to find F. So for that, substitute this A either in equation 1 or equation 2. I'm going to use equation 1. F cos, this value is 78.876 equals to, it says 50 under root 3 minus 76. When you divide these two, the cos term and the other 50 under root 3 minus 76 term, you get F equals 54.955, which rounds off to F is equals to 55.0. So we've managed to find F by finding alpha first. Part 2. Given that the box is moving with a constant speed, state the magnitude of the frictional force acting on the box and hence find the coefficient of friction between the box and the floor. Okay. First, we need to find the frictional force acting on the box. Let me look at the question again. Given that the box is moving at a constant speed, if it's constant speed, that means we're using the formula speed is equals to distance over time, since the acceleration is 0. Also, it says constant speed. Okay. So acceleration is 0. That means forward force equals backward force. Because for forward minus backward is equals to MA becomes 0 in place of MA, and then forward force is equals to backward force. Okay, given that the box is moving with a constant speed, state the magnitude of the frictional force acting on the box, and hence find the coefficient of friction. Okay, so all these forces, F, 100 and 120 Newton, they have a resultant force. We will need that. Let's find R for all these three forces. The link is about to end. The meeting is about to end. I'm sending you guys a new link. Given that the box is moving with a constant speed, state the magnitude of the frictional force acting on the box. Okay, so if the box is moving at a constant speed, what direction is it moving in? See, it was told initially that the resultant force is only in this x direction. So this is the direction of the resultant force. So it's going to move in the direction of the resultant of the three forces acting. It's going to move in the direction of R, and R is now going to be your forward force. So forward force is equals to backward force. It says that the surface is rough. That means the backward force is the frictional force. Friction is equals to mu R. This is the resultant, not the normal contact wali R. That's the resultant, and the other R is the normal contact R. Okay, so we know that friction is actually equals to the resultant force, because forward force is equals to backward force. This is the formula we've used. Okay. Secondly, friction is mu R. And resultant force was already given in the question. It was 136 newtons. Okay. Now we need R, which is the normal contact force, which is in this direction. And that is mg, so 40 times 10, 400. So mu times 400 equals 136. This should give mu. Yes, mu comes out to be 0.34.